lesson 18, power series. Okay, a power series is a series of a form. Okay, you've got a constant, some constant in terms of n. So a number times x to the n. So when n is 0, you get c0 x to the 0, which is just c0. When n is 1, you get c1 x to the 1. When n is 2, you get c2 x to the 2, and so forth. But these, keeping in mind, these c's are all constants. Okay, and it goes forever again. Or more generally, you could have, instead of just x, you could have x minus a number to the power of n. So in this case, this a value was just 0. It's like x minus 0 to the n. But more generally, a could be something else. So x minus some value of a constant again, and you get the same sort of expansion, but with x minus a to the 1, x minus a to the 2, and so forth. So we again want to know when this is convergent. The convergence of a power series will often, but not always, depend on the value of x. For example, consider this series where Cn equals 1 for all n. So this then becomes, 1 x to the 0, which is 1. 1 times x to the 1, which is x. 1 times x to the 2, which is x squared, and so forth. Now, just like the whole geometric series, we're multiplying by x, so x is r. Therefore, it's only convergence when the absolute value of x is less than 1, just like for a normal convergence series when the absolute value of r is less than 1. Make sense? So we use the ratio test to determine the convergence of a power series. So, as a reminder, how does the ratio test go? What do we check? Limit? Yes, of?
N to infinity of a n plus 1.
Yes.
Over a n.
And what kind of values, what if it's less than 1, what does that mean?
It's
Convergent.
absolutely convergent.
Ooh, sorry. No, I'm kidding, that's good. And what if it's equal to 1?
Inconclusive.
Yes.
Did you find that question where I was like proving inconclusive?
What if it's bigger than 1?
It's divergent.
Divergent. Okay, so that's a little reminder of the ratio test if you need it. Okay, so let's have a go. For what values of x is blah, blah, blah convergent? So in other words, I want to know when this is less than 1, right? Let's have a go. Okay, so what is an? Beautiful. So what is an plus 1? I think it's worth writing these out before you sub them in, okay? What is n plus 1? An plus 1. Beautiful. And so I need to find the limit as n approaches infinity of that. That becomes, okay, I'm going to go slow. It's an plus 1 is x minus 3 to the n plus 1 over n plus 1. And I'm dividing by x minus 3, 3 to the n over n. Well, that was a bit messy, but anyway. Which becomes, and I'll do the flip before I try to cancel anything out. All right, so what happens?
You get rid of the x minus 3 to the n on the bottom and then the n plus 1.
Mm-hmm. And that's pretty much it, isn't it?
Yeah.
Oh, okay, yep, so let's keep going. So that becomes the limit as n approaches infinity of n times x minus 3 over n plus 1. All right, I know the x minus 3 might confuse you, but what would we normally do at this stage, keeping in mind it's n approaching infinity, not x? Divide by n, exactly. Let's divide the top and bottom by n. We get the limit as n approaches infinity of x minus 3 over, yep, beautiful. And as n approaches infinity, what does that all become? Yep, but the absolute value, yes. So is everything okay?
Yeah.
All right, I'm just sorry if you run out of room. Let's go over here. So, woo. I'll get there. So we need the absolute value of x minus 3 to be less than 1. And I want to find the x values, right? So what do you think I'm going to do now? Solve an inequality. And how do I solve an absolute value inequality? Split it into... What's my two inequalities?
X minus 3
is less than 1 and... Oh, yeah, you can do it that way. Here's the thing. My concern about doing less than -1, it actually will be the wrong sign. You have to flip it. So that's why I always make the negative here. So on this side, if I add 3 to both sides, I get x is less than 4. On this side, I get negative x plus 3 is less than 1. Minus 3 to both sides, negative x is less than -2. So if I divide by -1, I now have to flip the sign. X is bigger than 2. So it seems like we're finished, but we're not. What happens? We're close though, we're very, very close. No, don't do that. Damn it. Anyway. What happens, that's when it's convergent, but what's something else we need to consider? For instance, we don't want divergent, obviously, but what if it equals 1? We actually don't know if it's convergent or not, so we need to check it. So now we're going, again, okay. Now, let's check when x minus 3 equals 1. And brackets for your notes maybe, I'm just going to, this is where the ratio test is inconclusive. In other words, we really do need to check it. And that's when x equals 4, and that's when x equals 2. So they're the two things we're going to check now. Is everything okay? So girls, you can see the series on your page. What does the series look like if x equals 4? We get the sum of n is 1 to infinity of 1 over n. X minus 3 to the n over n, right? Yep. So it becomes 1 over n. Anything you know about that? Do you recognize it? It's divergent. How do you know that? P-series or P-test. Yes, either one, yes. So this is divergent, and in brackets how you know which is P-series or the P-test. That's good that you knew that. That's excellent. What about when x is 2? What does it become? Oh, good, an alternative one. It's like this. If it's an alternative alternative series, do you either just know what it is, or do you know what we need to check? What do we need to
check whether it's decreasing?
Yes. We first need to check if bn plus 1 over bn is less than 1. So, what is bn plus 1 over bn? What's bn plus 1? -1. Oh, actually, no, you're right. Sorry. Because you don't include the -1 bit in the bn, do you? It's what we're timesing the -1 bit. Divided by 1 on n, which is n on n plus 1. And this is less than 1.
Yes.
Therefore, it's decreasing. If you want, you can write therefore it's decreasing. And what's the other thing we need to check? The limit as n approaches infinity of bn, which is the limit as n approaches infinity of, which was what we want it to be. Therefore, it's convergent. Okay. See, I should have left you more room. Anyway, so therefore convergent. So take a moment, look at everything, and tell me what x values is the original series convergent. Good, less than 4, not equal to, because it was divergent. So in conclusion, it's convergent for these values of x. We did everything, but here I probably should write alternate or alternating series. Now, because we wrote them throughout the solution, that's enough. We don't need to go by blah, 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 blah. That's the good news. If a power series is absolutely convergent when x is b, then it's also convergent when x is less than b, or the size of x is less than the size of b. Does that make sense? I mean, if it's convergent when x is 2, the other ones are going to be smaller, so it's kind of like the comparison test. If that one comes down, it's convergent, so is the other ones. You know what I mean? Because they're smaller. Okay, power series. For a power series where blah, 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 there exists only 3 possibilities for convergence. The series converges maybe only when x is a. That's kind of like saying back here. So let me explain this. So when x is a, that becomes a minus a, which is 0, which is kind of like when x is 0, and that's convergent. Does that make sense? I'm comparing it to the previous statement. The series converges for all x in R, so every value of x, or there exists an R such that the series converges if x minus a is less than R, and diverges if it's bigger. That's kind of like saying our R was our previous b, but now we have also x minus a. It's kind of like comparing it to that value. Does that make sense? So, a power series has a radius of convergence of R. If R is this value here, if R is the greatest number such that the series converges for all x in R such that x minus a less than R, and diverges for x minus a greater than R. So that sounds very formal, but we'll actually use it in an example shortly. If this series only converges when x is a, we say R is 0 because that kind of makes sense, because then we would say x minus a actually becomes 0. So it's kind of like less than or equal to 0. So R is 0. If the series converges when x for all R, there is no R, there is no bound. Therefore, we say R is infinity because it converges for any x value. And the interval of convergence, I, is the series of all points x for which the power series converges. So R is the bound, I is the set of all the values of x. So there's an example down here. So first of all, I'll read. Most of the interval of convergence may be deduced from the radius of convergence. However, we need to consider the convergence for the cases absolute value of x minus a equals R separately. So first we consider when it's less than R, then we need to consider when it's equal to R. In other words, for instance, we saw in example 36, so previously, that when n is 1 to infinity, x minus 3 to the n over n converges. For when x is between 2 and 4 but equal to 2. So what does that mean? Let's think about this for a second. This was from the statement of this, x minus 3 less than 1. We got that in our working somewhere in that previous example. Therefore, that number there is R. Do you see that? Does that make sense? Our A is 3 in this case. Not that we generally have to find A, but that is A. And this is like the set of values for the interval of convergence. Does that make sense? So the R is 1, the interval is this set of x values. So see how they're different? But we can use this statement to work out that set of intervals, which is exactly what we did. And we also considered when x equals 2 and when x equals 4 separately as well, which is exactly what they're saying in the previous line. So we've kind of used it already. We just didn't know we were using radius and interval. We actually used them in the previous example. Okay, so let's have a go. Another one. Question 2. Find the radius of convergence and interval of convergence for that. So, last time we got to that statement using the ratio test. Do you remember in the last example? So let's do that again, ratio test. Okay, so let's see what happens. The limit as n approaches infinity of an plus 1 over an equals the limit as n approaches infinity of... Okay, an plus 1 is x to the n plus 1 over n plus 1 factorial divided by x to the n over n factorial. That's an. Sorry, does that all make sense? You can just go from yours. You don't even have to check mine. Just up to you. You just keep simplifying this. So what happens as n approaches infinity? The whole thing just becomes 0 because x is just one value. Even if it's huge, n's going to get bigger than that. So that approaches 0, which is less than 1. Now, that's going to work for every x because x is not part of that expression of 0. We've left x behind. That's going to be less than 1 for any value of x. Does that make sense? So therefore, it converges for all x in R. So, there is no bound on x. So, what is the radius of convergence? Infinite. So, R is infinity, or the radius of convergence, I should say. And what's the interval of convergence, the set of x values? Yeah, so basically all x in R, that is a set. Now, I haven't done B yet, so that was all A. Now, I'm going to put B over here. All right. Hence, show that the limit of x to the n over n factorial equals 0. Actually, we don't really need to show anything, do we? What do we know? If that series converges, the limit of the term should equal 0, right? So we can just explain. Since this n equals 0 to infinity of x to the n over n factorial converges, then the limit as n approaches infinity of x to the n over n factorial does equal 0. It's converging for all x in R, then the limit is 0 for all x in R. Find the radius and interval of convergence for this thing. Girls, where are we going to start with? Ratio test. And, okay, you go, I'll go, and let's meet once we've done the limit bit, all right? So, like, what's the first thing you're writing down? Tell me.
A n equals x to the n of root n plus 1.
Yep. Wait. And -3. Isn't it? Yeah.
Is there a practical way that we can try and use the alternating sum and get rid of
Yeah. But you have to keep the 3 to the n in there. Okay, are you with me there? Beautiful. Girls, what can I take out of that limit?
-3.
Yep, and because it's an absolute value sign, it becomes 3. I can take something else out too. The x, because the limit's only in terms of n. But when I take x out, what do I have to also include? As in, I can't just write this. Absolute value sign, because it's the absolute value of that expression. So x could still be negative or positive. And so then it becomes just, and you can think of it as the square root of n plus 1 over n plus 2, like that. Or you can write them as separate square roots. Now, thoughts on this limit? What? You can, but I don't really need to. I could divide all the terms inside the square root by n. Now, girls, I just didn't write the absolute value. Why am I allowed to do that technically? Square root will always be positive, yep. And what does that become? Yes, it does, good. It becomes the square root of 1, which is just 1. So it's the 3 times the absolute value of x. All right, so what does that have to be for convergence? Less than? Okay, now, I'm going to write that down for convergence. But here's the thing. The whole radius idea is x minus little a is less than r. I don't have a number out here. So what should I do? Like, I need it to look like something like this. If a is 0, that's fine. So I can have this. I need to divide by 3. I can't have 3 on the outside. So if I divide both sides by 3, I get the absolute value of x is less than 1/3. So girls, what is my radius of convergence? 1/3. So therefore r is 1/3. Is everyone okay so far? We're not finished though. So my interval, it looks like it would be x is between, yep. But what am I supposed to also check? When it's equal to 1. So back here, I also need to check when this thing equals 1. I need to check that because the ratio test doesn't tell me enough about that. Is everything okay? So what about when x equals? So what are the two things I need to check when x equals negative 1/3? And I might put it in here when x equals 1/3. Okay, let's keep going. So when x equals negative 1/3, let's put that in our series. We get n equals, 0 to infinity of negative 3 to the n times 1/3 to the n over root n plus 1. And this becomes, what does that become? What's on the top now? Negative 1 to the n on the top? Yep, over root n plus 1, beautiful, okay. What's that? What type of series is that? An alternating series. Now, sorry girls, it's taking more room again. I'll write this out and go in here now. So now I'm continuing in there. Okay, so if that's an alternating series, what do I have to check conversions? And the limit. Okay, so let's do it. What is bn plus 1? 1 over root n plus 2. And is that less than or equal to 1 over root n plus 1? Yes, because the denominator is bigger. So that's true. Oh, yes, I am doing a third. Okay, so should we just change it to checking x equals 3? Sorry, I copied the wrong bit from my notes. Whoops. So we're just checking x equals third instead of x equals negative a third. Sorry, thank you. All right, does this approach 0? Yep. So therefore it's convergent when x equals a third. Is everyone okay? Now let's check when x equals negative a third. What do we get? Take a moment. But I'm going to write it out just to make sure. Can you read that? I feel like I'm writing so small. Oh, but it's pretty big. So what does that become? Whoa, 0 to infinity. Now we have. So this is approximately the integral of 1 on root x plus 1 dx. How are we doing? Okay. How do I, first of all, it's an infinite integral, so what do I do? How do I find it? The limit as b approaches infinity of 0 to b. And I might rewrite the whole thing. That's x plus 1 to the negative half dx, which equals, the limit as b approaches infinity of x plus 1 to the half divided by a half, which is like timesing by 2. Which becomes, you could take 2 out if you wanted and get the limit as b approaches infinity of, put b in there, I get root b plus 1, put 0 in there, I get root 1. What happens here? Infinity. Oh, yes. Yeah, that's all right. That approaches infinity, it's not a finite value, so what does that mean? So it's not finite, not that I should have to write that really. Therefore, it's not convergent, or divergent, I should say. Whoops. Therefore, to finish off, the interval of convergence is, take a moment, I'll let you catch up, look through everything and tell me what the interval of convergence is. Mm-hmm. And it's the third that was equal? Yes. Yes, that was the first one we did, yes. Beautiful. And that is the interval of convergence. So, something to remember, we need the ratio test to get to the, it is ratio, isn't it? To get to the interval of convergence, because that's the one that has the absolute value signs. And that helps us get there. So that's good to note.